Hello, mathematician. Welcome to today's math lesson. Today we are going to be working with large numbers. The first thing that we want to make sure is that we have our materials ready. Today you're going to need your math journal and a pencil. And you can go ahead and pause the video and go get your materials if you don't have them with you. And you can also pause the video and draw your place value chart because we're going to be using a place value chart to help us work with these large numbers today. All right, well, let's get started. Our learning goals for today are that we will identify base 10 relationships between digits and numbers up to 1 billion. And then we also are going to be working on representing the value of digits and numbers up to 1 billion using expanded notation. So let's get started. If we're going to be working with large numbers up to 1 billion today, we need to have a good understanding of what place value is. Place value means the value of a digit based on its place in a number. And so here we have a number on our place value chart, and we see digits placed in different places. Digits are numerals that are used to make up a number, and each digit will have a value based on the place that it is within the number. So let's take a better understanding of the word place as it pertains to place value. Place is a digit's position within a number. Here we see that the digit 5 is in the hundreds place. And what that tells us is it tells us its value. That 5 is not just a 5. That 5 has a value of 500 because it's in the hundreds place. So that's how we understand values of numbers based on their place. So we're going to be working with values of very large numbers today, up to 1 billion. So here is our place value chart. We begin on the right side of our place value chart with the ones period. Then we have the thousands period that contains thousands, 10,000s, and 100,000s. Then it grows to the millions period, which has millions, 10 millions, and 100 millions. And then we would have the billions period. You'll notice that each period in our number is separated by a comma. Now let's look at the relationships that we can find in digits in our base 10 number system. As we notice, as we start in the ones place, the place with the least value, as we move towards the left, our places grow in value. They get bigger. And so we can start by thinking of this as how many ones does it take to make a 10? How many ones does it take to make a 10? Well, it takes 10. There are 10 ones in a 10. Well, how many 10s does it take to make 100? It takes 10 10s to make 100. Well, what about 1,000? How many hundreds does it take to make 1,000? You said it, 10 again. So we're noticing a pattern here. Every time we move from a smaller place to a larger place, the place one place to the left, it gets 10 times greater. When we move from the ones place to the tens place, the tens is 10 times greater than the ones. The hundreds is 10 times greater than the tens. The thousands is 10 times greater than the hundreds. So each place to the left is 10 times greater the place to its right. But what if we wanted to go backwards? What if we wanted to go from a larger value to a smaller value? Well, in that case, the smaller value, the hundreds, would be 1/10 the thousands because hundreds are smaller than thousands. As we move from a larger place to the right to a smaller place, we're going 1/10. Think of it as 1/10 less. It's getting a 10th smaller. And you've noticed that whether we're growing bigger or smaller, we're dealing with tens. And that's why our number system is called a base 10 number system because it's built on utilizing tens. All right, now let's apply this to a question. And we're going to use our place value chart, so make sure yours is set up and ready to go. Our question says a factory produced 77,700 toys in 1 year. Which statement about this number is true? So true, I'm going to circle that. That tells us we want what is correct. And our number, we're going to start by looking at our strategy. We have a strategy for each type of question. This is a base 10 relationships question. So we start with drawing our place value chart, which we have ready to go here. We're going to plug in the digits to our number and then label our base 10 relationships, 10 times greater and 1/10 less. So let's take a moment to place our number on our place value chart, 77,700. So I know that 77,000 starts in the 10,000s place. So I'm going to start there. 77,000, don't forget your comma, 700. Okay, now let's label our base 10 relationships. Remember, we saw those here. As we grow to a greater place, it's 10 times greater. As we move to the right, our places get less in value, so it's 1/10 less, the place to its left. So let's label that. So here, let's start with moving to 10 times greater. So we know that the tens is 10 times greater than the ones. The hundreds is 10 times greater than the tens. The thousands is 10 times greater than the hundreds. And the 10,000s is 10 times greater than the thousands. But now let's go the opposite direction. Let's move to the right on our place value chart. So our values are going to get smaller as we move to the right. So we know that 10,000 is the greater place. So the thousands is 1/10 less than the 10,000s because the thousands is smaller. The hundreds is 1/10 less than the thousands because it's smaller. The tens is 1/10 less than the hundreds. And the ones is 1/10 less than the tens. So now we've labeled our base 10 relationships, and so now we have everything we need to help us process through the answer choices. Let's look at A. The value of the digit in the hundreds place is 10 times the value of the digit in the thousands place. So here it says we're going from the hundreds, let's find it. We're going from the hundreds place to the thousands place. So if we're moving from the hundreds to the thousands, is that the hundreds is 10 times the value? Is hundreds greater than thousands? No, hundreds are less than thousands. So it would be 1/10 less. So this is not true. 100s are not 10 times the value. They're 1/10. So bye-bye A. Let's look at B. The value of the digit in the 10,000s place is equal to the value of the digit in the thousands place. Equal. Does that make sense? Are 10,000s the same value as thousands? Are they worth the same? No, 10,000s is 10 times more than thousands. So they're definitely not equal. So bye-bye B. C, the value of the digit in the thousands place is 1/10. The value of the digit in the 10,000s place. So here we have thousands. Here we have 10,000s. Thousands are smaller than 10,000s. So does it make sense to say thousands are 1/10 the value of 10,000s? Remember, 1/10 means smaller, and are thousands smaller in value? Yes. So this one, that one's sounding pretty good. But are we going to stop here? No. A mathematician doesn't stop. A mathematician checks every answer choice because you never know. We could have made a mistake. So let's take a look at D. The value of the digit in the hundreds place is 1/10 the value of the digit in the tens place. Okay, so we're going from hundreds to tens. So here's hundreds and here's tens. Well, hundreds are bigger in value than tens. So would it make sense to say it's 1/10? Because remember, that means less. No, hundreds would be 10 times the tens. So no, that is not correct. So C is the correct answer choice. Awesome job, mathematicians. It took a lot of thinking there. Now you're going to have a chance to try at the end of this video. In the next section of your lesson, you'll complete your You Try questions. This is going to be one of your You Try questions. It says a warehouse shipped 55,555 boxes last month. Which statement about this number is true? You're going to do the exact same strategy that we did here. Put your number on your place value chart. Label your base 10 relationships. Remember, when we're moving from a place to the right that is smaller to a place that is bigger in value, we're doing 10 times the value. When we're moving from a place that is greater to smaller in value, that smaller place is 1/10 the value of the greater place. Remember that you also have anchor charts in your lesson module that you can also access to see these anchor charts that we went over if you need to look at them again. All right, here in the next part of our lesson, we are going to be representing numbers. And here is a quick review on the different ways that you can represent a number. Standard form is when we write a number written with the digits 0 through 9. It's the regular way we write our number using numerals. Expanded form is where you're decomposing a number showing the value of every digit in the number. And then expanded notation is decomposing the number, but this time using times its place value. You're taking the digit and then timesing it by its place value. So let's take a look at an example. Here we can see we have a number in the billions, 1,253,713,864. Let's pull out one of these digits and look at the value. Let's pull out the 3. Here we see that this 3 is in the millions place, so it has a value of 3 million. I can zoom in there for you. It has a value of 3 million. And now if we wanted to represent that digit's value in expanded notation, we would say that the 3 is in the 1 millionth place. 3 times 1 million would be 3 million. And so you can read this by saying that there is a 3 in the 1 millionth place. All right. Well, now let's try one. Get your place value chart ready for your next question. If you need to pause the video, you can. Here we have a number represented in expanded notation, and we want to know what is this number in standard form. So it says, what do you notice about the values? When we look at these values, do you notice anything interesting? Yes, we are missing some of the values from our place value chart. So that tells us that we might have some sneaky zeros in this number. All right, let's look at our strategy. Our strategy is we draw our place value chart and we plug in our digits based on the values that we're given for each digit. And that will give us the standard form of our number. So here we go. Let's start with a 4 times 10 million. We can read that by saying 4 in the 10 millions place. So let's find the 10 millions place in our number, in our place value chart. Here it is. And we're going to put a 4. Okay, our next value, 2 times 1 million. We can read that as 2 in the millions place. So find your millions place. Here it is. And we'll put a 2. Our next value, 6 times 10,000. Remember, think of that as 6 in the 10,000s place. Let's find the 10,000s place. Here it is right here. So that is where our 6 goes. And now let's look at the next value, 3 times 100. 3 in the hundreds. Here's our hundreds. Plug in a 3. 7 times 10. 7 in the tens. And 4 times 1. 4 in the ones. Well, that's all the values that they gave us. What are you noticing here on your place value chart? What do you notice? We have some missing values, don't we, within our number? Where do we need to put sneaky zeros? We need a sneaky 0 in the thousands, and we need a sneaky 0 in the 100,000s. Do we have to place a 0 in those places? Yes, we do. If we don't put zeros in those places, then that changes the value of our whole number. Our number would become 426,374 instead of the number that we now have. Let's write it. We need to put in our commas first. And let's write our number as we read it. 42,060,374. So now we have written it out with our numerals, and so that is the standard form of our number. So now we need to go through with a very careful eye and look to see which one of these answer choices matches exactly with what we got with our place value chart. So I'm going to give you a moment, take a look at those answer choices very carefully, and see if you can find which one matches our number. You can pause the video to take your time. Did you choose B? Choose B? Excellent job. B matches our number. 42,060,374. Excellent job, mathematicians. All right, then at the end of this video, you will go to the next section of your lesson module and answer your you-try questions. Here is your you-try question for expanded notation. Which statement about the number below is true? 504,360,090. Remember your strategy. Draw your place value chart and plug in your digits based on the values you are given so that you're able to see which one of these digit values is correct. All right, mathematicians, thank you so much for learning with me today. See you next time.